And what we're going to do is we're going to practice what we're doing in class. We're working really, really hard on this thing called the equal values method. Equal values method. And equal values is an algebra strategy of figuring out where do two lines cross on a graph. And it's a way to do it without having to actually draw the graph itself. It's really kind of nice sometimes. So let's do this. Let's say we had the rules y equals, and the first rule was negative 2x plus 3. So y equals negative 2x plus 3. And the second rule was y equals, we'll say 1/3 x minus 4. If I ask you to graph both these lines, at this point we're getting better and better and better at that. So hopefully if I said graph these lines, you guys could kind of do it. So I want you to try it. Pause the video and draw a graph and figure out where do these two lines cross each other. So go ahead and do that. Alright, so I'm hoping you've unpaused the video and now you're going to kind of follow along with me and see if you did your lines correctly. So those two rules that we got, one of them started at plus 3, so one of them starts about here. It says 3, so right about there is 3. And it has a growth of minus 2, so you're going to be counting down 2 over 1. So down 2 over 1, right about there. Down 2 over 1. It's a little harder on the iPad, but down 2 over 1. So I'm going to get a line that goes to points, and it's probably going to look something in this direction. So something kind of like that. And it's going to extend both ways, so it's going up that direction as well. And then I'm going to go ahead and work on my other line. My other line starts at negative 4, so at 1, 2, 3, 4 down, negative 4 is down here. So right about there is my starting point. And then it has a growth of 1/3. It's going up 1 over 3, up 1 over 3. So if you think about that, up 1 over 3, we're going to have this point of intersection right away. 1, 2, 3 over. So what I'll do is I'll make a line that goes through all of those points. So maybe something more like this, if you think about it like that. And you can see the point of intersection. You can see that it's happening right around here. So there it is, point of intersection. If your graph and my graph kind of match up, then you know you're in the right direction. Well, you want to be able to kind of figure out this point of intersection. I'm going to call it POI, point of intersection. You want to be able to find it without having to draw the picture every time. So if you look really closely, I guess we need to know where is this at. So it looks like it's at 1, 2, 3 over, if you calculate it right, and negative 3 down. So I'm going to write it's at 3, negative 3. That's my guess. And now I want to get that exact same answer without doing all of this work. So now we try a different method. The new method is going to be equal values. We're going to take those rules. Remember the rule was y equals negative 2x plus 3. And the other rule was y equals 1/3 x minus 4. And the equal values method says take the two rules, set them equal to each other. So take negative 2x plus 3 and set it equal to 1/3 x minus 4. Put a line down the middle, solve for x. So with the fraction, I always like to get rid of the fractions. That 1/3's kind of, it's a little bit problematic. So let's get rid of it. If you want to get rid of a fraction, you can times it by the bottom number. You can times it by 3. But that means you're going to have to do that to everything. So you're going to have to times the 4 by a 3. You're going to have to times this by 3. You're going to have to times the negative 2x by 3. Everything times 3 times 3 times 3. And so if I do that, these will cancel, which will be great. That's what I want. And then I got to go through and do all the math. 3 times negative 2 is a negative 6x. Plus 3 times 3 is 9. Equals the fraction's gone, so all I have is a 1x. Minus 4 times 3 is 12. So I get it all the way down to this. Then what I'm going to do is let's move this 6x over and make it a positive 6x. I'd rather have positive x's. So I'm going to have 9 equals 1x plus 6x is 7x minus 12. I'm going to flip that 12 over, so it's a positive 12 over here. Let's do that next. And 9 plus 12, I can do that math pretty easily. That's 21. So 21 equals 7x. And at this point, I know my very last step is going to be to divide by 7. So divide by 7, divide by 7. Barely fit it down there. And if you divide by 7, you're going to get 21 divided by 7 is 3. So we get 3 equals x. Perfect. Exactly what we got when we drew our graph. Now, to get the rest of the answer, we still got to do one more thing. We got to solve for y. So now, I'm going to go all the way over here, and I'm going to write solve for y. Solve for y. And remember, to solve for y, the strategy is pick one of the rules. Either rule will work. So I'm going to pick the easy one without the fraction. I'm going to do y equals negative 2x plus 3. And I need a little bit of space here, so I'm going to erase some of this. I wouldn't normally erase, but I'm running out of room. So I'm going to erase just a little bit of this. So remember what we got for an answer? We got x equaled 3 over here. Since I know x is 3, or I think x is 3, I'm going to put that 3 here where the x is. I'm going to circle the x and turn it into a 3. So I'm going to have y equals negative 2x will be negative 2 times 3 plus 3. And then negative 2 times 3, I'll do the math, is negative 6 plus 3. And negative 6 plus 3 is negative 3. So I get y equals negative 3. And then this kind of backs up my answer from earlier. I got 3 and negative 3. That's exactly what I saw in the graph. And I write it like a point 3 comma negative 3. And that's my answer. So hopefully you kind of followed me on those steps. Will you guys try one now? Will you take this problem, so we'll call this the next example here, and will you solve for where these lines cross? And I'm going to give you 2 lines. I'm going to give you y equals 1/2 x. We'll say plus 1. And the other rule is going to be y equals, we'll do 3x minus 9. 3x minus 9. I could graph this, but it has a minus 9, so I'm going to have to go all the way down to negative 9 and put my first point. This is going to be a big graph. I don't want to graph it. So if I don't want to do that, let's go straight to the equal values method. Pause the video and try it. Go straight to solving for x and y. Okay, so if you're solving for x, you're taking the 1/2 x plus 1 and set it equal to 3x minus 9. You're setting the 2 rules equal to each other. And it's this big line down the middle, solve for x problem. You're going to get rid of the fraction right off the bat. We're going to say, let's get rid of that thing by timesing it by 2. But then I got to times this by 2, and this by 2, and this by 2. Times 2, times 2, times 2, times everything. And that'll do what I want. It'll get rid of the fraction, so I just have a 1x. Plus, 1 times 2 is 2, and 3 times 2 is 6x, minus 9 times 2 is 18. Oops. So 18. And now I'm ready, if you can get it down to here, now I'm ready to solve. It'll be easy. I'm going to take the 1x, move it over, make it a negative 1x. So 6 minus 1 is 5x. So I have 5x minus 18. And left on the other side, now that the 1x is gone, I still have a 2. So I'll move the 18 over to this side, make it a positive 18. And 18 and 2 added together make 20, so I have 20 equals 5x. And so the last step, we know what to do in the last step. What do we do, guys? And we divide by 5. So we divide by 5, we divide by 5, and 20 divided by 5, that'll be our answer. And our answer is going to be 4. 4 equals x. There we go. So if you did this and you got x equals 4, nice job, guys. That's exactly what you want to do. So now I'm going to go over here and I'm going to solve for y. Solve for y. And to solve for y, remember you pick one of the equations, whichever one you like better. So I don't want to do the fraction one, I want to do the non-fraction one just because it's easier. So I'm going to do 3x minus 9. And now that I think I have an answer, I think the answer is x equals 4. Now I can take the x, put the 4 in there. So instead of like a 3x, you can have a 3 times 4 minus 9. So y equals 3 times 4 minus 9. Now I'm just doing math. 3 times 4, that's 12. So I have 12 minus 9 equals y. And 12 minus 9, that's 3. I can do that too. So I get y equals 3. So I now officially can say, I know this is really messy, but I can look at it and say 4 and 3 on the graph. If I went over 4 up 3, there's going to be a dot there, and there's going to be 2 lines crossing through it. I can safely say that. And you might even want to do this. I'll erase so you can see this, but you might want to write your final answer as if it's a point on a graph. You might actually want to write 4, 3 in a parenthesis. Probably the best way to show your answer would be kind of like that. Just kind of something to think about.